Highly welcome. Of course, today we'll be having an introductory class on organic aspect of chemistry. So I want you to just stay glued. I'm going to start from the very scratch. Yes, we're not here to waste your time, rather to intimate and help you have the necessary knowledge as regard organic chemistry. Since this is a live session, I will just tell you one or two things about that. This is intro. Yeah, introduction. This is an organic chemistry class. Take note. Now, without wasting much time, I want you to understand that okay, let's deal with what I call probably origin and of course meaning of this meaning of organic chemistry. Origin and meaning of organic chemistry. Please take note. I'll make everything very brief, straight and to the point. Yeah, without wasting time, I want you to understand that there have been a large number of organic molecules known before even 18th century. There have been a large number of these known before. And we have been taking this to be the chemistry of living origin. Just like when we have in biology, we talk about organization of life, where you have cell that performs similar function, we say it is what? Tissue of similar function, we say it's organ. Then organ will give rise to system, and we have different type of body system. Yeah, so you should know. So today I want you to understand a large number of organic molecules have been known since time immemorial, that is 18th centuries and all that. All of them were obtained from natural sources, which are the plants, otherwise known as flora species. Now, when we talk about, anytime you hear about flora, that is plants, that simply refers to plants, by plant sources. While whenever you hear about fauna, that is what? Animal. Is plants, this is animal or animal sources. Are you seeing it? So you should take note of this one. You have to calm down. Yeah. So all these are just the basic thing that you need to know. Like I said before, we have origin and meaning, and I'm telling you the word organic is coming from just like the chemistry of living origins. Yes. So you should know. All of them, say a large number have been known. Large number of what? Organic compounds have been known since time immemorial, which is the 18th centuries or before even 18th centuries. So all of them were obtained from natural sources. That natural sources can either be what? Plants or animals. So that is what where we are currently. And those things are like something we end up having is sucrose, starch, alcohol, and the rest of them. So you should take note of this. There is a transition to all these things. That is why our reason of being here today is just to go straight to the point. I know most of us have gone through all this. You have known one or two major forces as whenever we talk about organic chemistry. Of course, I mentioned different compound, starch, this. We're going to classification and other aspect of this work. Okay, without wasting much of your time, I want you to know it was generally believed that living organism produces this compound. That is in the before centuries ago. The earlier belief of organic was that living origin produces this compound. Are you seeing it now? That living origin produces it. So that is the earlier beliefs. So you should know that. So before, there are some forces like I know you have heard about a man known as Berzelius. Yeah, when we talk about historic development, I don't want to really delve into all this so that we can achieve something worthwhile. Yeah, Berzelius in 1807, or that is still 18th century, suggests that all those compounds that they got that time, though he did a whole lot, he was the one that brings some start giving compound name, that is Berzelius. So he suggested that this should be called organic, or those compounds that they got from a living origin in 18th century, that is 18th century, should be called organic. That is, it was generally believed that living organism produces this compound. That is one thing. And this thing, why do they just say living organism produces organic compound? Since it was an earlier belief, they hold to the principle of what they call vitalism, vital force. Vitalism, that there is something in these organisms that make them. So please let's not go to too much irrelevant. I know you have also heard of Friedrich Waller, 1828. It is this man that brought a unique, how would I put it, a modernization to organic chemistry. So it was this man, and what is his work? He was able to synthesize urea, urea, that is the work of this man, from an urea is organic in nature. I just want to say one or two things because we have a lot to talk about. He synthesized urea, which is organic in origin, from an inorganic substance known as ammonium cyanate. And that man is known as Friedrich Waller. Yeah, in 1828. 1828. See, 18th century scientist. So please let's not keep revolving around. Okay, maybe I promise I can do something on historic development so that I highlight the major pioneer that you need to know. This man's work is just this: NH4CNO, that is ammonium cyanate. He was able to synthesize, he got what we call urea, that is a C double bond, this NH2, then NH2. This is urea. Let me put it here. This is urea. That is urea. So he synthesized urea from this compound. This is inorganic compound and this is organic. With that, the initial belief or the principle that for you to be an organic compound you must come from a living origin was laid to rest. Yes, that is just it. That is the onslaught of this organic chemistry belief that organic compound are chemistry of living origins, or compound from living origin, compound obtained from living origin. That is why if you have gone through your chemistry textbook, there is what we call isolation and purification of an organic compound and the rest of them. So, but I want you to just follow through everything that you need to know as regard this. I'm going to explain it. So without wasting much time, I want you to understand that the word organic comes from the, just like we have organ, just like we have organ, meaning living. It comes from that word organ. Yeah. Organic chemistry was earlier defined as the study of nature, composition of compound. Nature, study of nature, composition of compound associated with living things. Those living things are still your flora and the fauna. Please a minute. Hello? So I got told them this is my phone number now. Phone number. Mana. Yes. Okay. So please sorry for the break in power transmission. Okay. Hello? Use my phone number now. This one. Yes. Mbao, how much? This way. Ayana. Just do my beg. There's no time. So sorry for that. Session. I'm trying to reduce distraction. So this is it. So the work of Friedrich Waller was to synthesize urea, organic in origin, from an inorganic known as ammonium cyanate. Are you saying it? So we are going somewhere. I want you to understand. Hello? Ope. All right. So now let's go to definition. Another necessary thing that we need to know. Sorry, that is, let's go to definition. Definition of an organic. Remember, it was initially being defined as the chemistry of what? Living origins. Yes. But now, based on the discovery that say, okay, organic compound must not necessarily come from a living source, you can also, that is what lead to the word laboratory work, which we call synthesis. That you cannot just always get everything about organic from a living origin. That there is also an aspect of it which can be obtained from maybe inorganic in the laboratory via synthesis. So that is why you have synthesis of, there are some organic compound that have been obtained through synthesis, and synthesis is actually a lab work. Now you see, now anytime we are talking about organic chemistry, mostly being defined in terms of what we call a carbon atom. Are you seeing it now? All right. Oh, someone at what say? Okay. Please, in case you have any question, feel free. We are together in this space. Yes. So this is a secret at. Okay. Anyway, please do well to follow through and keep sending. Some of you drop likes, send reaction to the video. If you are still following through, please do well to send reaction. It really means a lot to me. Yeah, send reaction to the video. I want you to share to others so that they can easily join us. It's just but for a few minutes, then we'll be done with this. Send reaction. God bless you. God bless you. God bless you. Okay, now by virtue of definition, I want you to understand organic chemistry is the study of carbon compounds. I'm going to give you reason for this. Yeah, it is the study of what? Carbon compound. Carbon compounds. That is it. Study of carbon compound. Pardon me, I have to short form compound. You already know what I mean by that. It is the study of what? Carbon compound, or simply chemistry study of carbon containing compounds. But there is an exception to this. There is an exception to that. Please take note. Take note. There are some compound of carbon that is not organic. There are some compound. Hold me by my distance. I said there are some compounds of. All right. So. Sorry for the break in power transmission. Yeah. Sorry. We are here again. Let's just see what we can achieve within few minutes of our time. Like I said before, my network got truncated. I said an organic chemistry is the chemistry study of what? Carbon compound. With exception to that. What are the exceptions? The exception we have to that definition is the oxides of carbon. Oxides. Of course, you and I know there are two oxides of carbon when we talk about the CO and the CO2. Now, I want to tell you one or two things aside the fact that we're on organic chemistry here. This is carbon 2 oxide or carbon monoxide. This is carbon 4 oxide or carbon dioxide. This is what the fire extinguishers use, because CO2 does not support combustion, whereas this support combustion. I just want to, anything we mention, I want you to, whenever you are in this space with me, make sure that you have your pen and paper and be jotting something down. That is the reason for this enlightenment. Now, this one support combustion. This one does not support combustion, whereas this one support combustion. Not just that. This is what we call acidic oxide of carbon, while this one is neutral oxide. No, just I give anyway. At time will come, I will be giving you shortcuts. Since I mentioned oxide, I don't know if I ask you what are the something like amphoteric oxide, you should be able to tell me this Zerat B. These are all the examples you need to know as regard your exam for what? Amphoteric oxide, zinc oxide, lead oxide, aluminum oxide, tin oxide, and beryllium oxide. Are you seeing it now? All this is what you call what? Amphoteric oxide. Then you are a neutral oxide. Another one is dinitrogen 1 oxide. Another one is water. Examples of neutral oxide. But let's go. I say organic chemistry is simply the chemistry study of carbon atom. Carbon compound. Carbon containing compound. It is a chemistry study of what? Carbon containing compound. But there are some compounds of carbon that is not organic. An example of those is what? Oxides. We have the oxides. Oxide is not, oxide as a compound of carbon is not organic. We also have carbides. Carbides. Can you give me like metallic carbides? For instance, calcium dicarbide. This is a carbide. Can also be magnesium, but metallic carbides. Carbide. Aside carbide, we have carbonates. That's carbonate of metal, like cacotely. Cacotely. I'm mentioning compounds of carbon that is not organic. You know what compound is, which is chemical combination of 2 or more elements. Mentioning them one after the other. We have so many of them. All these are not part of what? Organic compound. They are compounds of carbon, and they constitute what? Inorganic compounds of carbon. Remember, we still have sulfides, like we still have bicarbonates. Let me mention that. Bicarbonates. Yeah. We still have sulfides. Sulfides of carbon, like CS2. Sulfides, like CS2. Carbon disulfide. Are you seeing it? So that is it, or carbon 2 sulfide. All these are compounds of carbon, but they are not organic. Now there are so many questions to this, but even as we proceed, you get I want you to know, however, the presence of numerous organic compounds can be attributed to the following properties of carbon. So the presence of numerous organic compounds can be attributed. There are reasons why there are numerous organic compounds. One of those is that carbon freely combined with hydrogen and so many other elements. That is why when they ask you why is carbon essentially unique as an element of an organic, or the central atom of an organic chemistry, you talk about catenation. Start mentioning catenation, which is what makes it look so easy for carbon to combine with itself and other elements. That property is what we call catenation. Catenation. That is the ability of carbon to form multiplicity of bonds with itself and other elements. All these are the basic things that you'll be seeing even for these exams. You'll be seeing them. You should know. This is what makes carbon to form chains with itself and other elements. We call it catenation. So they're also different. You can talk about the tetravalency of carbon atom. Carbon is tetravalently bonded. Tetravalency. Are you seeing it? You can also talk about position of carbon. Tetravalent means there will always be 4 bonds pointing towards carbon. Be a single bond, or when you have it this way, double. Each carbon must have 4 bonds. Here, 2. This double bond is shared bond, shared between carbon. You can also have it this way to show 1 here, 1 here, 1, 2, 3, 4, 1, 2, 3, 4. So there must always be 4 bonds. You must to understand organic chemistry, you must know what is obtainable from a carbon. Just when I start talking about hybridization in this, you know there are different types of hybridization, but only 3 is obtainable in carbon, which is when we talk about your sp3 for carbon-carbon single bond, sp2 for carbon-carbon double bond, and sp for carbon-carbon triple bond. All these things, that is why we are going to be taking this bit by bit to ensure that every necessary thing that you need to know is well communicated. That is why keep following, keep dropping reaction to the video, share to others so that they can easily join us, and of course drop heart, and of course like the video, like the live session. All these things we encourage so that I know that I'm not just alone in this media space. Okay, now position. Now, what is the position about? Position of carbon in periodic table is in if you look at your periodic table, take this. Let me just take this as a periodic chart. Don't worry, take this. I just want to explain something. Let me partition it this way. We have the left and we have the right. I'm explaining something for you. Let's say carbon is here. Carbon is here. Carbon is positioned in such a way that elements here are the metals. What do you know about metals? They have the propensity or the ability to donate electron. They give out. Why elements here are the non-metals. What do you know about them? They have the propensity to what? Here, accept. They accept electron. Why here, what do? They donate electron. Now, what do you need to understand? Carbon being in between, neither donate nor accept. What does carbon do? Carbon choose to do what? Share. Are you seeing it? The position it found itself in the periodic table make it somewhat difficult for it to donate or to accept. Rather, it share electron. And this is one of the things that contributed immensely in the carbon forming multiplicity of compound or having numerous compound, both organic and inorganic. You should take note of that. Carbon share. It does not accept, neither does it donate. Rather, it share electron. It share with metals, share with non-metals, and all that. So that is one prominent thing again. Like I talk about catenation, I talk about tetravalency. You cannot see a carbon atom. See, you rather understand few or basic thing that you need to know. You cannot see a carbon this way. 1, 2, 3, 4, and another bond pointing this way. You are drawing attack. I see carbon cannot pass 4 bonds at every particular point in time. It's either you have it this way as single or true, or you have it, let's say this, something like this, single bond or true, or this double bond whereby you have one here, have one here, have one here, have one here, have one here. Hello? No life crash now, I beg. So that is it. Sorry for the sorry for the break in power transmission. I'm on call with my own mother. So going forward, what we need to do again, look at this. We have this carbon-carbon triple bond. You see, have one here, one here. Count each bond pointing to a carbon at a point. It must be 4. That is what is talking about, that tetravalency. No this and no p, so that even you myself go know what is obtainable at every point in time. And that is the reason for all these classes. You need to, that is why I call it foundation class. Foundation class. It's not just meant for, funny enough, it is meant for Jamb, WAEC, NECO, IJMB, JUPEB, even junior undergraduate like year 1, possibly year 2. I'm a chemistry major, year 3. You see, do some more. If I year 4, your final year of studying your BSc and all that, you see be revolving around most of what you are saying. Because if you miss it now, forget it. That is when the foundation will become faulty and all that. So please do well and for those of you that maybe it's not just this, every now and then we're always having a live session class. I want to, in case you want to join our online session, of course it's open to everybody. Do well, you can communicate to me or reach out to me on WhatsApp so that I'll add you to our group where you can easily be reminded that we're having a live session or because we always drop a reminder 09038 37 72 38. That is my phone number or my WhatsApp number. You can message me on that and I will add you to a group, because this season we are going to be giving you back to back. There is no two way about it. So I've mentioned so many things. Carbon freely combined with hydrogen, oxygen, nitrogen, and other elements. But all this one I mentioned is what you mostly see in the organic chemistry. Of course, different arrangement of same atom within a molecule produces variety of compound. When we talk about isomers, I'm trying to give you the reason why we have numerous organic compounds. Remember, these things were limited. When they say organic chemistry is the chemistry of living origins. But through the work of this man, Friedrich Waller, in 1828, who synthesized urea, organic in origin, from an inorganic compound known as ammonium cyanate, then the belief was gradual or fantastically laid to rest. You see that now it is no longer the chemistry of living origin, because we now have even the synthetic analog. You can go to laboratory and synthesize, produce organic from inorganic compound. Are you seeing it now? So it's now making sense. So I want you to just pay rapt attention. Carbon easily forms single bond, double bond, or covalent bond. Which is what I told you, catenation. So catenation of organic compound. So carbon easily form all those chains of this thing. So you should take note of that. And we talk about carbon atom have exceptional, that is the exceptional ability of carbon atom. So exceptional ability of a carbon atom, the form multiplicity, well done. So form multiplicity of bond with itself and other elements. You should take note of that. And that is the basic thing, because if you don't know what actually revolves around carbon, then you will not be able to comprehend in full notes what is not obtainable in carbon. So that is it. Because when you see a structure, you will know, oh, did I make a mistake, or is everything all right with this compound? So you should know. I've given you reason why carbon is the central atom of an organic chemistry. So in case you have any question, don't go with that. Just feel free to drop your question. You can drop your question. Let me attempt to it. Yes, you can drop a question. So please know, unique characteristic of an organic compound. Yeah, unique characteristic. There's something when we talk about okay. You got him next. I'll be okay. So unique properties of an organic chemistry. Unique properties. Something that make an organic chemistry unique. Got this. Sorry, we're turning over to the next page. Unique properties of an organic chemistry. Let me put it as CHM. Yeah, unique properties. Unique properties of an organic chemistry. Please keep sending more reaction to the video and share to others that need these services. Share to others. Share. Yes, share. I've been able to explain so many things. I've talked about catenation and other things that revolve around this. Yes. Please don't forget, number one, when we talk about unique properties, number one, please take notes. Number one, I'm waiting for you. I want you to understand that organic compounds are generally soluble in non-polar solvents. You have heard of the rules of dissolvability, like polar dissolve polar, while non-polar dissolve non-polar. Organic compound, I will repeat, organic compounds are generally soluble in non-polar solvent like benzene, C6H6, or ether, You know ether. That is an ether is isomeric with alcohol. Okay, tomorrow. So alcohol. This alcohol now. Look at ether. CH3O CH3. We call this ether. In fact, the functional group of ether is just this. So this methoxy methane or dimethyl ether, if you want to name the compound. I'm going to teach you the concept of naming, and that is why you shouldn't take our being here for granted for any reason. If actually you want to have, sorry, I'm a little bit disturbed at the initial state of this. I promise such won't repeat itself again. There will always be a coordinated class from the beginning to the end, and I want you to always pay rapt attention. And in case you have any question, please feel free to do where to drop your question. Keep sending reaction to the video. Send reaction. And nobody have actually liked my live session. Is that bad? Nobody have actually liked the live session. Even as I'm coming down for you to take note of what you're supposed to note. Someone should send, just like the live session. It's important. Just like the live session. Send likes to the live session. Yes, it's part of what is keeping us active here. Just like the live session. It's very necessary. Very, very necessary. Like the live session. Okay, let's keep moving. Believe that everything is all right. And of course, for those of you that are still paying attention, I promise you, you will testify about this. Organic compounds are generally, that is number one, they are what? Generally soluble in non-polar solvents. They are generally soluble in non-polar solvent like what? Benzene or ether. Yes, because these are non-polar solvent. Polar dissolve polar. Why non-polar dissolve non-polar? Since organic compounds are mostly non-polar, they tend to dissolve more in non-polar solvent than they do in polar. So they not really dissolve, or they sparingly dissolve in polar. So take note of that. So we're going somewhere. So that is number. We are talking about unique characteristic of an organic compound. Simply put, characteristic of an organic compound. Now another one is that they are insoluble in water, with exception to some special group. When we talk about those special group, most especially OH, you know, whenever you see OH, we refer to alcohol or phenol. Alcohol, most importantly. Yes, alcohol, most importantly. Take note of that. They are mainly, you know, organic compounds are mostly covalent in nature. They are covalent. That is mostly the type of bonding that we see there. They are covalent in nature. Of course, the solubility of organic compounds is due to their strong carbon-carbon bonds. So you should take note of that. So the covalence in them make them like a non-conductor of electricity. You know, when we talk about ionic compound or electrovalent compound, those ones can conduct electricity, but for covalent, they are non-conductors. So they are covalent in nature. You shouldn't forget that. So with that, they do not conduct electricity. So majority of the organic compounds are non-polar. Majority, except compounds such as chlorine, which is highly electronegative, or those consisting of a hydroxyl group. So that is it. The non-polar substances are mostly held together by these weak forces known as van der Waals forces. Yes, and you should know that most organic compound, another thing you should know when we talk about the unique properties of an organic compound is that most organic compounds are flammable. Of course, you need to understand that flammability and inflammability are talking about dissenting. They are what? Inflammable. Let me put it that way. And born exothermically. No, exothermic release heat, while endothermic absorb heat. With that, since they release heat, you can use them as source of energy. Yeah. Exothermically in abundance supply of air to yield mostly CO2 and water, that is steam. steam. They generally have low melting point and boiling point. Organic compound, one of their characteristics, they have low melting point and boiling point when compared to inorganic compound, not when compared to themselves. They have low melting point and boiling point when compared to what? Inorganic compounds. So you should take note of that. Most organic compounds are unstable to heat and they decompose into smaller molecules. Like when we talk about petroleum now, you see petroleum being the polymer units can be splitted via cracking into smaller useful products. You should take note. Chemical reaction involving organic compounds are much slower than ionic or than inorganic counterparts. Yes, the organic reaction are generally slow. They are generally slow. So I've made mention of something even before we reach here. So I told you something, that this thing is going to be bit by bit. Yeah, we're going to be facing it, everything that you need to know. Just like here, I told you there are three types. If I mention let's talk about hybridization before we end this session. Yeah, hybridization in carbon atom is carbon atom. Hybridization in carbon atoms. Of course, in carbon there are just three types of hybridization. We have the sp3 and sp2. Then we talk about the sp hybridize. These are the three types of hybridization that a carbon can undergo. Sorry, when we are here we teach. After this, I've made a lot of video answering different both JAMB question, WAEC, anything question that revolve around all these things. I've made a lot of videos and I'll be dropping most of the video that I've not yet posted. So you can still check back the YouTube channel on Let's Mentor, dig out those videos I've done across almost all these topics, all these things that we're doing now. So that is why this time around, in our live session we teach. After that, I solve question and post. So to complement what you have been doing here, and the question is highly rich. It's something that we just hit the nail exactly on the head as you want to say it. I take my little time to explain, and I make the video very brief. Is something that you can easily digest. So I will admonish and I will advise you to do it to engage those videos. Yeah, do it to engage them. And if you see my thing, I don't know whether you have seen my thumbnail. You see, okay, thumbnail, I'd not use that. I'd not use what I have a timetable for my live sessions. I will share that with you. So hybridization is no other thing than the missing. When we talk about hybridization, it is the missing or reshuffling to reshuffle something, or the blending together. Are we together? Is the missing of two or more orbitals of same energy level, that is same principal quantum number, to give new set of orbitals which are exactly equivalent. Look at a carbon atom. Sorry, we have carbon. The atomic number is 6. We have it as 1s2, 2s2, and 2p2. Yeah, 2 plus 2 plus 2 give us 6 electrons that we just shared. And how do we do this? That's according to Hofbauer principle. All these principles are necessary. Pauli's exclusion principle, what does it state? It says no two electrons in an atom have the identical set of 4 quantum numbers. Then we talk about Horn's rule that said electron must first be shared singly before pairing takes place in an atom. So we now go to this other one called Hofbauer or Hofbauer principle. And what does it say? It said Hofbauer says something that an electron must first occupy the lower energy level before that of the higher energy. I'm going to do separate video on those principles and explain them in a way that you can easily comprehend it. So I want you to just know that you're on the safer side, and whenever you are here, your biro and pen should be with you so that you jot down things. Jot down something that will help you very well to ace your exam. I have to take my time to explain all this. So sorry. Now, like I said, hybridization is the missing of two or more orbitals of same energy level, of course, same principal quantum number. Are you seeing it? To give new set of what? Orbitals, which are exactly equivalent. Hybridization is the missing of two or more orbitals of same principal quantum number, that is same energy level, to give new set of what? Orbitals, which are exactly equivalent. Are we together? So that is why, let me just explain this. For 1s, look at this. This is the electron configuration of carbon. What happened here is that one electron from this is the one of equal energy level. We call them degenerate orbitals. These are degenerate. They have same energy level, degenerates. So one electron will be promoted because you see what? S orbital have only one subshell. That is this 2s, 2s2. It should have been this way because S have only one subshell. But you see p orbital, which is our 2p and it's 2p2. P have 3 interior compartment or subshell. And now, according to Honsu, we say share 1, add 1. This one do not receive at all. It is vacant. So what happened is that one electron will be promoted from this down to this side because that is what we are hybridizing, just like in agriculture. You are carrying one trait or character to mix with another one. They will end up giving you a different product that is in between. At times may tend to be what? More stronger or viable because you have the feature of this and this that of this. So, but that aside, so here one electron will be promoted from 2s to meet this. So at the end, you see when they miss, you see something like this and things like this. This is our 2s. Only one electron is here now. This is our 2p. In this 2p, which side, that is 2p. Now you see one electron have been added, making it 3. So it can now be 1, 1, and 1. So these are what you will be missing together here in terms of sp3, sp2, and sp. In sp3, it shows that 1, 2s react with 3, 2p. Meaning all the p orbital combined with it. In sp2, it shows that 1, 2s react with, I'm going to still explain this because I want to end the live session here because of the distraction we got so far. React with 2, 2p. While in sp, it shows that 1, 2s just exactly react with 1, 2p. Meaning here, all the p orbital react with what? The 2s orbital. This is the only thing that when we talk about hybridization, this is the only thing that combine to give different set of hybridized orbitals. Here, all the p orbital react in sp3. Here, the two part of it, that is, for instance, in p orbital we have px, py, and pz. So you see that these two react and this one remain vacant. That is in this one. Let's say not that. I want you to understand these first two shall go into the reaction with 2s. Why this one is not? I'm going to explain this in a way so that you understand which one form your pi bonds, this or that, the unhybridized this. So I'm going to take time to explain those things now, but just understand this way. Referring to them now, know what actually combine because they usually form part of your exam question. So here the same thing, 1 and 1. Why 2 do not react? 2 are just like vacant. Of course they lead to formation of something and we're going to be discussing that subsequently. So please, I just want to take it that where we are is still on the definition of an organic chemistry because I'm going to add more effort to this, even if it is just on a live stream of 30 minutes on a day, not like, let me not say daily, on all the days that we're to be having activities here. Then that is really going to be wonderful. See you in my next class. Do it to keep flowing through. And whenever you have questions, feel free to ask. because I'm here to provide answer to all your questions. Thank you very much. I do really appreciate. See you when we see. Bye.